So the homework tonight, the 5.3b worksheet, is the same concepts that you dealt with yesterday, but now I want you to solve the problems. Instead of making one of those giant, tedious charts, I want you to use equations to solve the problems. Okay? The only reason I do those charts is because the charts help you kind of see how all of the numbers fit together. Okay? And I tend to have pretty good success with that. All right? So tonight you're going to solve the same types of problems but using equations. So I would like you to pull out a sheet of paper. I am going to write down what I see as an effective projectiles problem-solving strategy. 5 steps, and then the rest of the time is yours to work. Okay? Oh, and somebody, when I'm done going over this, when I'm done talking about the problem-solving strategy, somebody remind me to talk about this mess up here. Okay? It will make you happy. It'll take 2 seconds. All right, so solving projectiles problems. Step 1. Draw the projectile's trajectory. So what the bleep is a trajectory? It's a fancy physics word for the path that the projectile follows. Cool? So on tonight's homework, because all of our projectiles are being launched horizontally, that's going to just look like this. Cool? And then on the next assignment, we're going to have footballs being kicked at angles and Evel Knievel's jumping over canyons. And those are going to look like this. Okay, so draw the path that the object follows. That's step 1. As you do that, think about important time intervals. Okay, so like maybe it will say the ball reaches the top of its path after 4 seconds. So put a dot here and write t equals whatever it is. Call that TP, right? Or maybe it lands. Maybe I tell you how much time it's in the air total. Write that down on your drawing. Okay, so use those drawings to keep track of information that you're given. Follow? That's step 1. Very important. Good? Okay, step 2. Make a velocity vector triangle for any important points along the path. Okay, so what do I mean by that? So maybe it's a problem where somebody kicks a ball. Okay, great. Well then, maybe you're given information about the initial velocity at which the ball is kicked. Oh, well that velocity has a horizontal component and a vertical component. How come I labeled this one with an I but didn't put one on the X? Because it's constant, right? Okay, and here's my initial angle, right? So there's one triangle, indicating what was happening when the thing first got launched. Cool? And maybe the problem says, after 5 seconds, the ball is coming down at a velocity of blah, blah, blah. Great, draw that. So you might go, oh, well, after a time of whatever, here's my velocity. It's got a horizontal velocity, it's coming down now, so here's my final velocity, and here's my final vertical velocity. And there's some new angle for that triangle. Does that make sense, you guys? So you're going to have a different velocity triangle at any point along the object's motion. So maybe this velocity triangle represents what's happening right here, or whatever. Okay, and so having a triangle and associating it with a point along the path will make your life easier. Am I making sense or no? Questions? So to me, this is the hard part. Right? Remember first chapter, there were a bunch of people that were like, oh God, this is way easier if I write out my givens. This is writing out your givens for this chapter. It's making drawings and keeping all your stuff organized. Once you've done that, the problem solving is just wading through that giant list of equations. Good? So, unless people have questions on this, let me help you navigate those equations, and then I'll shut up and you can work. So, questions before I shut up? Okay. Step number 3 is super easy. So, oh, that's not what I wanted to do. Step number 3 is super easy. So, as you solve the problem, at any given instant in your problem-solving process, like you physically working through the problem, you're going to be either thinking about horizontal motion or vertical motion. Okay? You never combine the two. It's always either horizontal or vertical, unless you're looking at one of these triangles. That's the only time that you would ever combine the two. Clear? All right, which type of motion is simpler, the horizontal motion or the vertical? Horizontal, because the velocity is constant, right? There's only one equation. So step 3 in your problem solving is see if this equation helps. Right? Like maybe the problem says the ball lands 50 meters away after 4 seconds. Oh, cool. I know it lands 50 meters away. That's my delta x. Oh, I know it's in the air for however many seconds I just said. I know the time. I can find my Vx, right? So if you know 2 of these 3 variables, you can find the missing one. Follow?
It's a stupid question.
Not at all.
But in 2, like, do you know the numbers to put in the triangle?
It depends on the problem. Sometimes you will, sometimes you won't. But my recommendation is if you know even one of them, I would draw the triangle. Do you know what I mean?
Yeah.
And then just label the other sides and maybe just put in, like equals question mark or whatever. Cool?
Okay.
All right, everybody good? All right? And finally, step 4. Have I not used blue yet? I don't think I've used 4. Step 4 is if the horizontal motion doesn't help you, then you should think about your vertical displacement and your vertical velocity. So choose a time interval and think about delta y, the time elapsed, vertical acceleration, your initial vertical velocity, and your final vertical velocity. And then pick from one of those vertical equations and see if you can find something. So what do I mean when I say the vertical equations? Well, there's really 4 of them. There's the vertical equation that tells us about velocity. Our final vertical velocity is equal to our initial vertical velocity plus our vertical acceleration times time, right? It's just all the equations that deal with acceleration, right? So that's an equation we could use if we had the right information. You could use this guy. Oops, delta y equals 1/2 ay times t squared plus viy times t. You guys have all these equations. Delta y equals 1/2 vfy plus viy times t. And last one, delta y, 2ay delta y equals vfy squared minus viy squared. And see if you can find something. Cool? And sometimes you need to loop back in the process, but these are the 4 steps that you're going to follow, usually in this order, and then sometimes you got to go back. Like maybe doing this allows you to figure out the time, and then you can go back and use step number 3, right? Or whatever. Does that make sense, you guys? Okay, so that's kind of the deal. So tonight's homework is really just wading through all of that, okay? So do the best you can with it. Tomorrow, all we're doing is going over that assignment, okay? And if we finish early, then, I don't know, you can get started on the next section, I guess. But, cool? All right, cool. Last thing, problem number 5 on the worksheet has you finding out some information about a projectile launched and there's like 10 different angles or something. If you can do one of them, you can do any of them. So I don't want you to do all 10 angles. So what I want you to do is find your last name up here, okay? So if your last name is Mackinac, or however you say your last name, did I say it right? Mackinac. Did I say it right that time?
Yeah.
Close enough. So that's G. So he's going to do part G. And he doesn't have to worry about the others. Cool? We'll talk about this one tomorrow. This is like big concept. All right, good? Questions, concerns, anything? Okay, I'm shutting up. Full resource.